Hi everyone, welcome back to Science the Miss T. I am Miss T. In today's video, we are unlocking the ultimate cheat sheet for you to pass your organic chemistry reaction. In grade 12 technical science, the examiners love testing how molecules change structure and the exact conditions needed to make it happen. So we'll start by breaking down the three reaction pathways, that is combustion, addition, and substitution, and then we will crack an exam question from a past paper. So grab your notebook and let's get to it. The first reaction that we'll be looking at, which is the easiest of them all, is combustion. So combustion basically is the burning of hydrocarbons in the presence of oxygen. So do you still remember which ones are hydrocarbons? Hydrocarbons are the organic molecules that consist of carbons and hydrogens only. So your alkene, and alkynes. So for combustion to take place, we need excess oxygen. By the way, combustion is also known as oxidation. So examiners can interchange between combustion and oxidation. Don't get confused. So for a complete combustion reaction to take place, we must have excess oxygen. And combustion is an exothermic reaction, meaning it gives off a lot of thermal energy. So key, guys, this never changes. For a combustion reaction, there's always three products that are formed: carbon dioxide, water, and energy. Because combustion is an exothermic reaction, so we need to show that energy is given off. So whenever you're writing down your reaction for combustion, it is going to be what? Always the hydrocarbon. So I'm going to just give it CXY plus an oxygen. And it's always going to give you the three: CO2, H2O, plus the energy. So in most cases, they never really show the energy part in the reaction. They just show the carbon dioxide and the H2O. But nonetheless, please keep it in mind. Also, before we continue to addition, whenever you have a combustion reaction and you need to balance it, please, you're going to start balancing the carbon first, followed by the hydrogen, and the last one is going to be the oxygen. Always balance your combustion reaction in that order. Let's look at addition. Addition says it all. In order for me to be able to add something to something, there must be room for me to add that. So for addition reaction, we are going to be breaking the double bonds and adding something. So addition reaction, the golden rule, always takes place for unsaturated hydrocarbons, meaning I need to have a carbon, double bond, carbon. So we're saying it's unsaturated because I can break this bond and create an additional bond there and an additional bond there. So these two spaces have rooms for me to add something there. So the first reaction is hydrogenation. So hydrogenation, we are adding a hydrogen. Hydrogen addition. And hydrogen is a diatomic element, so meaning it's always going to be two of them, H2. So when we're adding the hydrogen, there must be a catalyst present. So the first catalyst that we can use is platinum, PT, palladium, PB, and then the last one, nickel, Ni. So these catalysts are dissolved in a nonpolar solvent. The second one is hydrohalogenation. Again, the name says it all. Halogenation. So meaning here we are hitting what is called a hydrogen halide. A hydrogen attached to a halogen. Hydrohalogenation. And one of the reaction conditions here is that there must be no water present. The third one, halogenation, we are adding what? Sorry, I did not put the plus there. So plus X2. So the X just represents the halogen. So the halogens that we can be putting here, it is going to be what? It can be your chlorine, it can be your fluorine, it can be your bromine, it can be your iodine. So basically all the halogens that are found in group 7 of your periodic table. The last one is hydration. Hydration says it all. If you're going to hydrate, it means you're going to do what? You're going to input water. You're going to add water, because for you to hydrate your body, you drink water. So hydration simply means we are adding excess water. And one of the things that is needed is a catalyst, which is a strong acid, which is sulfuric acid or phosphoric acid. If you can understand that, you'll never get an addition question wrong. Our final category is substitution reaction. Unlike addition, substitution happens for saturated molecules, meaning carbon, single bond, carbon. That is for a saturated molecule. So when we talk of a substitution reaction, think of it like a spot substitution. One atom leaves and the other atom substitutes the other one directly into its place. The first one is halogenation of alkanes. So here we swap the hydrogen atom with a halogen X, and this reaction can never take place in the dark because it strictly requires what? It strictly requires sunlight or UV light or mild heat for it to kick off. The second one is hydrolysis. So here we turn a haloalkane into an alcohol by doing what? By swapping the halogen with what? With a hydroxyl group, the OH group. To do this, you react it with a strong base like sodium hydroxide or potassium hydroxide dissolved in ethanol. And the last one is halogenation of alcohols. We do the reverse. Hydrolysis, we're taking the halogen out and substituting the OH. With halogenation of alcohols, we are taking the OH from the alcohol and we are putting the halogen. So the swap, the reverse. And in order for this to take place, we need to use a concentrated acid like hydrogen bromide or hydrochloric acid. Now let's apply everything we just learned to this exact flowchart from the November 2022 exam. If you can understand what we are doing now, you'll never get these questions wrong. So now I always tell my learners, analyze the flowchart before you answer anything else. So let's look at it. We start with an ethene. How does an ethene look like? Ethene is an unsaturated hydrocarbon. Why are we saying it's an unsaturated hydrocarbon? Because it has double bonds. So I have C, double bond, C. I have hydrogen, 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 hydrogen. So remember, all unsaturated hydrocarbons undergo what we call what? An addition reaction, because it requires us to break the bonds. So it means reaction 1 is going to be an addition reaction. Now, which type of addition reaction it is? If I look at my structure, the reactant that I started with had 4 hydrogen, and this one has 6 hydrogen, meaning I added a hydrogen. So the type of reaction is addition reaction. And what type of addition reaction is it? It is a hydrogenation reaction. And for that reaction to take place, I require what? I require a catalyst. The catalyst is going to be platinum or palladium or nickel. Now, this reaction, so now this product, it's no longer ethene, now it is ethane. So ethane undergoes reaction 2, where there's 2 compounds that forms. The moment I see this, I already know this is what? I added oxygen. So this means it is a combustion reaction, or it's what? It's oxidation. So it means here, I know that it's going to be CO2. Let's look at the reaction again. I moved from ethane to chloroethane, meaning one of the carbons has now a halogen added to it. Let's draw it out. C, C, Cl, H, H, H. Let's correct this. So what happened here? This is now a substitution reaction. The hydrogen is being substituted with a chlorine. So that means I added what here? I added HCl. So what type of reaction is this? So the type of reaction here is called what? Halogenation of alkanes. So I am moving from an alkane and I'm making a haloalkane. Hence halogenation of alkane. One of the requirements here is what? Remember, this reaction cannot happen by its own. It requires UV or sunlight or mild heat. Now, I have a fluoroethane. I add water. I get compound Y and then X. This means what? The halogen has been now swapped out and it's now replaced with an OH. So I don't know if I'm going to be able to draw it here. So C, C, O, H. And everything is the hydrogens. So what type of reaction is that? That is hydrolysis. We added water to remove the halogen so that we can get an alcohol. Hence, that is called hydrolysis. Remember, hydrolysis and hydration give us alcohols. Hydration is the addition and hydrolysis is the substitution. Don't confuse the two. So now we've analyzed, oh no, we're not done. For this reaction to take place, what are the reaction conditions that are needed? We need what? We need a strong base. So sodium hydroxide or potassium hydroxide. And remember, these two are dissolved in ethanol. Okay, so keep this in mind when you answer the following questions. So now we are just going to collect the answers from the flow chart and then write it down. 4.1, write down the type of reaction represented by the following. Reaction 1 is an addition reaction, which is hydrogenation. Reaction 3 is a substitution reaction, which type? Halogenation of alkanes. And then 4.2, use a molecular formula, write down a balanced chemical equation for the reaction. So remember, for a molecular formula, we list all the atoms that are within the compound. So for this one, I have 2 carbons and then I have 4 hydrogens. I'm adding a hydrogen, H2, and I'm getting a C2H6 compound. So let's check if it's balanced. 2 carbons, and then 6 hydrogens. So easy, 3 marks. 4.3, excess oxygen is the other reactant in reaction 2. We've already deduced that 2 things are forming. Carbon dioxide and water plus heat is given off because combustion is an exothermic reaction. So number 1, identify the type of reaction. It is a combustion reaction or an oxidation reaction. 4.3.2, write down the name of the formula of compound X. The name is carbon dioxide, and then the formula is going to be CO2. Mind you, the 2 is a subscript. Please be careful with that. 4.4, chloroethane reacts with water to form compound Y. We've already deduced that the compound that is going to form there is an alcohol. 4.1, type of reaction, substitution reaction. Which type? Hydrolysis. 4.2, two reaction conditions. Here they used water, meaning there was also heat, mild heat, that was needed for this reaction to take place. But we can also use what? And then 4.4.3, the name of compound Y, ethanol. And just like that, by applying our basic classification rules, we completely cleared every single mark for question 4. If you like this video, please give it a thumbs up, and don't forget, leave your comment down below if you have any questions for me, and I'll definitely answer it for you.